Today, I'd like to take a look at some of the different types of domestic hot water systems that may be found in the multifamily residential buildings. Starting with one of the more inefficient types, this is a gas-fired, standalone domestic hot water heater. Like any combustion appliance, air for combustion is required, and in this boiler room is brought in through an open louver in the back wall of the room. This hot water heater has its own aquastat and maintains 120-degree water to provide to the residents. As residents use that water, cooler water enters into the bottom of the hot water heater, causing a drop in the temperature. The aquastat then initiates the combustion process. It lights the combustion chamber, and through natural draft, air is drawn in to the bottom of the hot water heater to be used for combustion. Those gases travel up through the hot water heater, giving off their heat to the hot water, and eventually exiting the hot water heater through the breeching on top to carry it over to the chimney. This bell damper allows for dilution air to enter into the breeching in an attempt to maintain proper draft, so the gases of combustion will rise up through the chimney. One of the inefficiencies surrounding this hot water heater is the inability to control that natural draft. In some cases, poor draft or blockage in the breeching or the chimney can cause spillage, which will allow those gases of combustion to spill out of the bell damper, increasing the risk of carbon monoxide related issues. Some of the other inefficiencies surrounding this hot water heater are things like jacket losses. Because we're storing the 120-degree water in this hot water heater, that hot water is continually giving off its heat to the metal surrounding the hot water heater, which in turn is releasing that to the air and are considered energy losses. Another inefficiency is the volume of water that this domestic hot water heater actually contains. For this 6-story residential building, this hot water heater volume is not enough to satisfy the hot water demand to the residents, so a large storage tank is also required for this system to function. This leads to even more inefficiencies that we'll take a look at. After the water has been heated to 120 degrees Fahrenheit at the domestic hot water heater, it is circulated over to this 180-gallon storage tank. Because no combustion is taking place here, this storage tank can be heavily insulated to help to offset some of those jacket losses that we saw with the hot water heater itself. It has its own aquastat, and when the water temperature drops below 120 degrees, this aquastat initiates the operation of a small pump which pumps that water over to the hot water heater to be reheated back to 120 degrees. To review some of the inefficiencies that we've seen surrounding the standalone hot water heater, at the top of the list is the inability to control the draft through the combustion appliance. Natural draft combustion appliances are inherently inefficient and also pose serious safety issues surrounding carbon monoxide. Also, because combustion is taking place in the hot water heater, the inability to further insulate that hot water heater cannot reduce any of the jacket losses. Simple things like insulating all hot water piping and also ensuring that all pumps associated with the domestic hot water system are at the highest efficiency are all items to be looked at when trying to improve the overall efficiency of the standalone domestic hot water system. This 26-story multifamily residential building decided to incorporate its domestic hot water system directly into the steam boiler that it uses for heating in the wintertime. The tankless system, as it is referred, uses a hot water coil that's actually mounted in the boiler just below the upper water line of the steam boiler. During winter operation, the water in that coil is continually being heated due to the steam process of heating the building. But in summertime, auxiliary components such as aquastats take over the operation of the boiler to provide domestic hot water all year round. As tenants begin to use the domestic hot water in the building, Cold water will begin to flow into the hot water coil to be heated by the boiler water. As it exits, this water may reach temperatures of 180 or 190 degrees, which is way too hot for our domestic water. So it exits the boiler and heads on over to what we call the mixing valve, a required component in the tankless system. At the mixing valve, hot water that has just exited the boiler is met with cooler water and mixed to provide 120 degree hot water leaving the mixing valve to provide throughout the building. Although there are different types of mixing valves, some mechanical in nature and some electronic mixing, their purpose is the same: to reduce the domestic hot water temperature down to a safe temperature that can be used for domestic hot water. One small advantage in using the tankless domestic hot water system is that the footprint for that domestic hot water system is incorporated directly into the footprint of the boiler that's used for the heating system. This can save valuable space in the mechanical and boiler room. Some of the inefficiencies associated with the tankless system include the overheating of the domestic hot water by nature of the steam boiler, and using a mixing valve to have to reduce that temperature down to a usable 120 degrees Fahrenheit. Also, heating this large volume of water in the summertime is extremely inefficient just to provide the domestic hot water required to satisfy the building. Hot water pipe insulation, the efficiency of electric motors used to operate pumps associated with the domestic hot water system, and the accuracy of sensors, aquastats, and controls that operate this particular system are crucially important components when looking to increase the efficiencies of the tankless hot water system. Another type of domestic hot water system that may be encountered in large-scale multifamily residential buildings is a type of indirect system. This system uses a hydronic or steam boiler to produce hot water or steam that is sent over to a small plate frame heat exchanger. On the other side of that plate frame heat exchanger, cooled domestic water is passed through the heat exchanger to be heated for hot water use by the residents. Small domestic hot water pumps take the cooler water from the storage tanks, pump it through the plate frame heat exchanger to absorb the heat and be raised to 120 degrees Fahrenheit for the residents to use. Due to the small volume of water contained in the plate frame heat exchanger and the large heating demand for domestic hot water in this 33-story multifamily residential building, 2 large storage tanks will be required in order to meet that demand. These 2 storage tanks are heavily insulated to prevent the jacket losses that we've seen with other types of systems. Although any type of boiler can be used to provide the mechanical hot water or steam required for the indirect hot water system, the efficiency of this system relies heavily on the efficient combustion taking place at the boiler. This building highlights efficiency by using a hydronic condensing hot water boiler in order to produce that mechanical water. In conjunction with that, they're using high-efficiency pumps controlled by variable frequency drives, which also significantly increase the efficiency of the overall system. Other areas of efficiency that need to be looked at with the indirect system are good maintenance and cleaning of the plate frame heat exchanger for heat transfer, hot water piping installation, and also the efficiency of the small domestic hot water pumps required to operate the indirect system. This next 30-story multifamily residential building uses a series of semi-instantaneous hot water heaters to keep up with the high domestic hot water demand in a large building. As tenants use domestic hot water, cold water moves into the shell of the semi-instantaneous hot water heater. A small pump continually mixes the water inside the shell in order to give the thermostat up on top an average water temperature. As that temperature falls below the standard 120 degrees Fahrenheit for domestic hot water, the thermostat begins to initiate the steam valve to open and send steam into a steam coil which is submerged around the domestic hot water. This steam transfers its heat to the domestic hot water, and that water exits out of the top of the semi-instantaneous hot water heater. Steam condensate gets removed from the steam coil through an F&T trap at the bottom of the semi-instantaneous hot water heater. Multiple heaters are used for different zones of the building in order to reduce the load and ensure proper hot water temperature to each area of the building. Efficiencies surrounding the semi-instantaneous hot water heater vary greatly depending on the availability and the production of the steam required for their use. In buildings using district steam for heating and hot water services, the availability of the steam can be very advantageous in the use of the semi-instantaneous hot water heating system. When producing that steam on site, boilers will need to run 365 days a year, not only to produce heat for the building, but to provide hot water, and the efficiency will vary greatly based on the combustion efficiency of that boiler. Some of the qualities of the semi-instantaneous hot water heater that make it so advantageous is its relatively small footprint, but its ability to have a rapid recovery rate and keep up with very high demand for domestic hot water loads inside the building. In summary, the efficiencies of the semi-instantaneous hot water heater vary greatly based on the steam production and how efficiently it is being produced. Other efficiencies, like motor efficiencies surrounding the pumps, piping insulation, and also steam trap maintenance, are important components that will vary the efficiency of the semi-instantaneous hot water heater. Now that we have taken a look at many different types of domestic hot water systems that may be found inside the multifamily residential building, they all have one thing in common. They are a major building system which can be a source of energy waste and inefficiencies if left unchecked. Domestic hot water systems should be inspected and evaluated anytime a building is looking to reduce their energy costs and increase the overall efficiency of their building systems.